In our previous video, we created three subclasses of vehicle: Neon, Cavalier, and Prius. We also saw that we can make the variable the superclass type and then have the object type be the subclass type. We saw that we can get different methods available depending on the variable type, and we can get different behavior depending on the object type. So in this video, we're going to make a simplified factory method. Now, factory method is a design pattern, and a design pattern is a concept that's very interesting and one that I like quite a bit. The idea is that we can use a certain design of Java classes to solve several different problems, possibly unrelated issues as well. So it's the idea that we see an architecture and we give it a name. And then when we refer to this architecture, we refer to it by its name, which is universally understood by programmers, so that we don't have to describe the details. We can just give it a name. And when I say giving a name to architecture, it's similar to giving a name to architecture of buildings. If I say Baroque style or contemporary or Georgian architecture, any of those common names of building architecture, I can just say the name and you can picture the building. For example, Georgian architecture tends to have bricks and windows just like this building that we see here. So it tends to be this kind of like what you see at Miami University, where you have the bricks and the white windows, roof like this. Typically, the windows get smaller as you go up in the building. It kind of gives a perception of height. So that's a similar concept that we use in software design, where we give these patterns a name. This one's called the factory method. Later, we're going to see one called the command pattern, which is one of my absolute favorites. We'll cover that in a different video. Now, I am taking one little simplified step with this factory method, and that is I'm doing it all in one class instead of using subclasses. Don't worry about that just yet, though. So what I'm going to do is we have three different types of cars. We have Cavalier, Neon, and Prius. And I'm going to add an additional prompt here that's going to ask the user which type of car do you want to create. So let's use our J option pane, and then we'll say show. This one I think we want to do, show input dialog will work, but we want to do one of these longer signatures like this one down here where we give it a drop-down list of values. So, okay, parent component is null. Okay, message is going to be choose a car to create. Okay, title, choose a car. For the icon, we'll say J option pane. Or sorry, the message type, joptionpane.questionMessage. Icon, we'll leave it the default, so we'll make that null. Now, I need a list of options to give. I need to create an array for that. So let's go ahead and do that now. So let's say string available cars equals new string. And actually, we can do it the long way. Remember this way where we give it like a capacity of 3. But remember with arrays, and especially with string arrays, there's a little shortcut we can do where we can say string, square brackets, available cars equals, and then curly, and then we can just make a comma-separated list of strings here. So I can say neon, comma, Cavalier, and then after the double quote comma, and then finally Prius. Okay? And close curly and terminate with a semicolon. Now this is good, but we know we do not like string literals. We much prefer constants. So I'm going to hold Shift Alt C. I'm going to click on neon, and we're going to make a constant out of that called neon. I'm going to put my cursor on Cavalier, Shift Alt C again, and we'll choose Cavalier. Okay, and Prius, Shift Alt C, and we'll click on Prius. And what's happening as I'm doing this is NetBeans is kind enough to create some constants for me. So if you take a look down here, it kind of put them in a funny place, but nonetheless, Prius, Neon, and Cavalier. Okay, so back up to my show input dialog now. For the options I want to give the user, I'm going to say available cars. And for the default value, let's go with the most simple case. We'll say neon, and we'll use the constant there, and then finally terminate with the semicolon. Okay, looks like I'm available cars. There we go. Looks like I misspelled something. And finally, we'll save. Now, just a quick run to see how this is going to look when we run it. I'll right click and I'll choose run. Looks like not available. Try one more time. Okay, run file. There we go. And you see what we've created now, a drop-down box with Neon, Cavalier, and Prius. We're not doing anything with it just yet, but we will in just a moment. Oops, sorry. Okay, let me just get out of these prompts and we'll go back. And there we go. Okay, so now what we want to do, if the user chose Neon, we want this word following new to be Neon. If the user chose Cavalier, we want it to be Cavalier down here. For Prius, we want it to be Prius. Now we could do an if test right here, which would be fine. Let me run over to the show input dialog. Shift-Alt-V will take this method and assign the result of that method to a variable. We'll say selected car, for instance, just like so. Okay, so what I could do now is, well, I'm going to do just a couple more things to make my life a little bit easier. But I'm going to say if selected car dot toString dot equals ignore case, and then I could say neon. You see, I can do it like so. Open curly, then we'll say my vehicle equals new neon. Okay, and then we'll do an else if. Okay, and I'll use this syntax again. And I'll say else if selected car equals new, let's say Cavalier. Okay, open curly, then we'll say my vehicle equals new Cavalier. Okay, and finally we'll say else. I'll go ahead and put an else if, and we'll paste that again, and this time Prius. But to be honest, because we have a limited selection that the user can choose from, that could be an else, but really else if is probably better. As a matter of fact, what I might do, open curly and then close curly here, my vehicle equals new Prius. That looks good, if I spell else correctly. This should cover all cases, but it is possible that none of these would evaluate to true. That would be only if we changed available cars, maybe we're reading it from a file, something like that. So good practice would be else. Then we need to record that this case should not happen. So we might want to put a log statement in, or we could even say throw new exception, unrecognized car. We want to log if we've gotten to this point and the user somehow got here without selecting Neon, Cavalier, and Prius. Even though it's logically impossible, if this drop-down list should change in the future, that's when we might need to adjust this if test to handle that. So throw new exception, it says unreported exception. I'll go ahead, Alt-Enter, and I'll add a throws clause. You'll remember that we had, we talked about exceptions in a previous video. Now up here, Alt-Enter, surround statement with try catch, and I might just put up here JOption pane dot show message dialog, and I'll say null, comma, unknown car selected, program terminating. Okay, and there we go. So at this point, we have chosen the user has chosen a car, and we've put together an if test so that we will create an object that is just like whatever option the user has chosen. Okay, one thing though, take a look at our prompt user method. Our prompt user method is starting to get pretty long and hard to manage. We don't want to make methods that are this long. So what I'm going to do is I'm going to highlight this if test block. I'm going to right click and I'm going to say refactor, and I'm going to say introduce and then method. Okay, and we're going to call this create vehicle, and I'll choose OK. Okay, and what we've essentially done here is we have created a factory method, a very simple factory method. And this factory method is going to take that selected car, whatever the user chose from the drop-down box, and it's going to run it through that same if test and then create a vehicle, one of the subclasses, Neon, Cavalier, or Prius, and then return that vehicle. I am going to make this a little bit more efficient. I don't really need this second parameter here. What I can do is I can cut it. Okay, we'll just make this a one parameter method. and then declare vehicle my vehicle up here. So it's going to declare the variable here, assign an object to it here, and then return it here. Okay, so let me run back up and clean up the call to this method. Just make it look like this. That's fine. Okay, now let me tidy up a little bit. Okay, and save. Now, if we look at this, we're declaring a local variable. Remember, local means it's only available in the local method. A local variable called myVehicle. And then we're assigning that on line 52. But we're assigning that. Remember what the assignment operator is. It's a equal sign. And what that means is execute what's on the right and assign it to the variable on the left. So what's on the right? This new mini factory method we've made called createVehicle. This createVehicle method is just accepting essentially a string, okay? And then it's running that string through an if test. If test creates the appropriate object and returns it. Let me put some JavaDoc up here, and I'll say simple factory method to create and return a subclass of type vehicle. Okay, param selected car, a string representing the vehicle we want to create, and then return the created vehicle. Now look at something very interesting here. Do you see how the object type Neon, Cavalier, and Prius, do you see what those are? And do you see how we're returning that? Well, look at the method declaration. Look at the method signature and take a look at the return type. Do you see how the return type is vehicle? Okay. What if I tried to make the return type Neon? Okay. Well, then we get a red line here that says incompatible types, vehicle cannot be converted to Neon. Vehicle is a more general case, Neon is a more specific case. Let's visualize this a slightly different way. On line 122, I can simply say return new Neon. On line 124, I can say return new Cavalier. And on line 126, I can say return new Prius. And at this point, I no longer need line number 120. So do you see when the return type is Neon, this is okay, the other two are not. Now let's change it to Cavalier. Okay, now take a look. Return new Cavalier is fine, but return new Neon says incompatible types, which means we're trying to return something, but the declared return type in the method is different from what we're returning. Prius, again, incompatible types. Let me change the return type to Prius again, and let's take a look. Now Neon and Cavalier won't compile, but Prius will. See, that's the tricky part about one of these factory methods, is the return type. If we make the return type a subclass, then our factory method does not work. The way that our factory method works is if we look at what is common across each three of these classes, Neon, Cavalier, and Prius. And the one thing that's common across each of these classes is that each one of them extends vehicle. That means that each one of them can look like a vehicle if needed. So for this factory method, I'm going to say public static vehicle, create vehicle, and now you see all three compile. A Neon is a Neon is also a vehicle. A Cavalier is a Cavalier is also a vehicle, and a Prius is a Prius, but a Prius is also a vehicle. Because each of these extend vehicle, it's okay and it's a good idea to use vehicle as the return type of this method. And that's a very interesting concept in object-oriented programming. So I'm going to snap a breakpoint here, and it looks like we already have a breakpoint here. I'll take that guy off. We have a breakpoint up above here. That's fine. So we have a few breakpoints. I'm going to save, and let's run this in the debugger, and let's watch what happens. So debug file. Okay. Okay. And debug, and we're going to say we want to step over, which is F8. So we're going to say F8. Okay. You see that the green line, the mint green line, goes from my breakpoint on line 45 down to line 48. Now we create a dropdown, okay, or we create the possible values for the dropdown, and now we say, okay, I'm going to prompt the user and say, okay, do you want a vehicle? Just a moment, let me, there we go. Sometimes that pop-up box appears behind NetBeans. So let's go ahead and say, I'll tell you what, let's say Prius this time, and I'm going to choose okay. Okay, now, very important, look at where the mint green line is. It's on line number 52. So what I want to do is I want to look inside of this method called createVehicle. If I just wanted the method to run and I didn't care to look inside, I would choose F8. But in this case, I want to see what's going to happen when I walk into that method. And let's see what we know so far. What is selected car? I mouse over it and take a look. You see that little hint that came up said it's called Prius. What's in my vehicle? At this point, my vehicle is not known. It's something that has not yet been initialized. But selected car, if you see that, see how that is the string called Prius. So I'm going to shift and F7, which will step me into that createVehicle method. And now we're going to say, is selected car equal to neon? Well, no, it's not. It's a Prius. Okay, so I choose F8. Is selected car equal to Cavalier? Okay, well, no, it's not because selected car is Prius. F8 again. Is selected car equal to Prius? And sure enough, those two things are one and the same. And by the way, I will say, note that I'm using the equals ignore case method, not the double equals. Remember in Java, when you're comparing strings, you typically care about the content inside the strings. In other words, the characters that make up the string. If that's what you want to compare, use either the equals method if you want a case-sensitive comparison, or equals ignore case if you want a case-insensitive comparison. But don't use the double equals. In Java, the double equals is comparing the objects themselves. In other words, the physical place in memory where these objects are, which you could potentially have two strings that look identical but occupy different places in memory. That's why we always want to use equals ignore case when comparing strings. So I choose F8, and now take a look at where we are. We're on line 126, which is going to create and return a new Prius object. So I choose F8, and I choose F8 again, and now let's take a look at my vehicle. You see, when I highlight my vehicle, it shows that it actually is a vehicle of type Prius. If I look in the Variables tab, we're going to see something very interesting here. And you see that my vehicle, if I expand this, you see the type here says Prius. And you see that it has milliamp hours and miles per milliamp hour. If you watched the previous video, you'd know that these are two attributes that we declared in Prius, but not in the superclass called vehicle. Vehicle has gallons of gas, odometer, miles per gallon. Now back down to this Variables tab, you see my vehicle, which is a Prius, and you see these two Prius specific attributes, but then click on Inherited and take a look. You see gallons of gas, miles per gallon, and odometer, which it is inheriting from the superclass called vehicle. Okay, so let's keep walking. Enter gallons of gas, we'll say 10. Okay, and F8 again. Okay, enter miles per gallon. Well, for a Prius, we better say at least 40. And F8, enter odometer. Again, it's a Prius, probably gets drive quite a bit, so we'll say 50,000. Okay, now do we want to create another vehicle? We're going to say no. Okay, F8. Now we're going to go into prompt for trips. Remember, I'll choose F7 if I want to step into this method, or I'll choose F8 if I just want to execute the method and run to the next line. So F8, enter distance travel 100 miles, reimbursement rate 44, and I don't want to create another trip. Now we're doing our loop within a loop that we created in a previous video. And what we're doing with our Prius now is we're going to run it the 100-mile trip that we just created. So we print the state before running the vehicle, and we do a little test to make sure we have enough gas. Now, look very closely where I am right now. The mint green line is on 100. And take a look at this. This vehicle.go, and it's going to send a trip down there. Okay. Now, the question that I have for you is which go method is getting called? It looks like I called it run here. That really should be go. Let me go ahead and fix that. You get the idea though. So it's the method, there's a method in class Prius. If I can get down in here. There we go. And there's a method with an identical name in class vehicle. So this is what we call overriding, where a subclass has the same method signature as its superclass. Let me show you what I mean. If we take a look at vehicle, you see public void go int distance. If we take a look at Prius, we see public void go int distance. Now, here's the question for you. The variable type is vehicle, the object type is Prius. which go method are we going to call when we choose F7? The one in Prius or the one in vehicle? And if you saw the last video, you probably might be able to make an educated guess. So let me go ahead and choose F7 and watch the tabs across the top of the screen, because that's going to tell you where this go method is. So F7, and take a look, we're in Prius. But notice what happens when I choose F8 and then F7 now. Super.go distance, we go up to vehicle. And then I'll press 8, and eventually we'll come right back to driver. That's why I say when using inheritance, extension, overriding, overloading, the debugger is your best friend. Okay, now we're going to print what happened after running, and then a reimbursement total. And at this point now, our program is finished, and we can take a look at the output if we want. So there we go. So started with 10 gallons of gas and an odometer of 50,000, ended with 8 gallons of gas and an odometer of 50,100. So this simple factory method has the word create, which is common for a factory method. It has some indication of what we want to create. It will create an object out of a subclass, and then the return type is the superclass type that all of those subclasses have in common. Now, in a true factory method, a lot of times this actual decision of what to make would be in a subclass of our class called driver or some other subclass, but let's not worry about that right now. This is a more simplified method. So I hope this has been helpful. And in the next video, we're going to see a very interesting way that we can shortcut this, which is pretty handy. I'll see you then.